After object literals, JavaScript arrays are the second main data structure that we use to create a collection of values. An array can be declared with square brackets containing the individual values separated by a comma. Here we have an array that consists of two items, both are of type string, the first one being Jane and the second one being Pete. JavaScript arrays come with a length property that indicates the number of items that are present. For example, here we have two people, so people.length is going to be the numeric 2. We can access the individual items within the array using a square bracket notation and passing in the index for the element that we want to access. Like all good programming languages, JavaScript arrays are zero indexed, which means the first element is 0 and the second element is index 1. Now if you pass in an index that is actually not present within the array, the JavaScript runtimes gives us that special value that we've talked about before called undefined. Now just like we can read a value using the index notation, we can write a value to a particular index as well by using an assignment expression. So here we are replacing the first element, which is the element at 0 index, from Jane to Kim, and now if you log out people again, you can see that it is now updated. We started off with an array that contained two items, but of course we can create arrays that have no items, have a single item, or as many items as we need. JavaScript arrays are completely untyped and they don't really care about what values you put inside of them. For example, here is an array that contains a string and an object and even a nested array. We can access the individual items as you would expect. For example, things 0 is gold, and we can continue our selection syntax based on the element that is present at that index. For example, the item at index 1 is an object and therefore we can access its properties using the dot notation. Similarly, the item at index 2 is an array, which means that we can continue selecting the individual items of the subarray by using further index selections. And of course, in addition to reading, we can use the assignment expression as well. For example, here we are replacing the string house with the string home. Now technically within JavaScript, an array is an object. So as an example, if we have an array and we use the type of operator, we get back the literal string object. Now this poses a bit of a problem because this is exactly what is returned for all objects. Fortunately, modern JavaScript has a function built in as a part of the array module called isArray, which will return true if the variable is an array, and for other objects it will return false. Arrays provide methods push, pop, shift, and unshift to add and remove individual tail and head items, and this allows us to build stacks and queues. So let's take a look at how they work and get some understanding of their runtime complexity. We start off with an array that has two items, first and second, and we can push additional items at the end of the array using the built-in push method. This gives us the array containing first, second, third, and fourth. We can remove items from the end of the array by using the corresponding pop method. So we get fourth and then third, and now the original array contains just the strings first and second. If you continue to pop, once we run out of the elements, it will start to return undefined. The time complexity for array methods is based upon how many index need to be changed. So for push and pop, only one index needs to be changed, which is the last element, and therefore the time complexity is O of 1 or constant time. Now JavaScript methods also provide the opportunity to modify the start of the array. For example, we start with an array consisting of economy and deal, and we can push to the start using Unshift, business, and then VIP to give us the array VIP, business, economy, deal. JavaScript also provides methods to remove an element from the start of the array called shift, and if we remove the first item, it would give us VIP, then we would get business, leaving just economy and deal within the array. Now just like pop, if we continue to shift till we run out of elements, it will start to give us undefined. For shift and unshift, n indexes need to be changed as all the items need to be either shifted right for unshift or shifted left for shift, and therefore the time complexity for these functions is O of n or linear time. So let's take a look at how we can implement stacks and queues in JavaScript and the impact of these operations. First up, let's implement a last in first out data structure, also called a stack, and we can do this quite easily by using the built-in push method to push items into the array and then pop the individual items from the end of the array so that they come out in last in first out order. As we've discussed, both push and pop are O of 1, so this is actually quite a nice performing stack. Now let's talk about how we can create a first in first out data structure, also called a queue. For this, we would still use push to push the items at the end of the array because it performs quite nicely. However, since we need them out in the first in first out fashion, we will shift them out from the front of the array using shift, However, as we've discussed, Shift does perform in linear time, so this is not ideal. However, when you are looking for a convenient queue, you can use the built-in JavaScript array for that purpose. JavaScript offers special syntax for destructuring arrays, that is, taking the members of an array and distributing them into different variables. For example, here we have an array consisting of 3 items, gold, iron, and copper, and we can get the first 2 items and put them into their individual variables by using the destructuring syntax, which looks very similar to the structuring or creation syntax, except that it is on the other side of the equal sign. This syntax also allows us to skip over an item by using 2 commas consecutively. For example, here we are skipping over the second member, which is iron. We can also use rest elements to grab all the remaining items and put them into their own array. For example, here the first item gold is put into uno, and the other 2 items are put into their own array in the resto variable. One thing to be aware of with rest elements is that they must be the last element in the destructuring. If we try to use them before that, we will get an error that it should be the last one. Now we can destructure more elements than they actually are in the array. For example, here we don't have 4 elements, and yet we try to destructure the 4th into quatre, and of course the JavaScript runtime in this particular case gives us undefined. Now with destructuring, you can also provide default values, and they will kick in whenever the value would have been undefined otherwise. For example, in this particular case, since there is no 4th element, it would have been undefined, and therefore it is going to default to silver. The modern spread operator that works with JavaScript object literals is also supported for JavaScript arrays. The spread operator can be used to spread the items of one array into another one. For example, here we have some white minerals, and then we have some more minerals within which we want to use all the white minerals, and we can spread them in with the triple dot spread operator. You can actually use the spread operator in any portion of the array. For example, here we are putting silver and platinum between gold and copper, and you can even use it multiple times. For example, starting with iron, we are spreading in the white minerals followed by yellow minerals to get iron, silver, platinum, gold, and copper. The spread operator is actually quite useful, and it has a number of use cases. For example, it is the recommended modern syntax for combining 2 arrays. So if we want to combine the white and the yellow minerals, we can spread them both into a new combined array. Now you might recall that push and shift causes a mutation of the original array. So if you want to add an item at the end or the start of an array without mutating the original, you can spread the original into a new array at the required place. Spread can also be used for the simple task of creating a copy of an array to prevent accidental mutations to the original. For example, here we create a copy of the white minerals, and when we push iron into this copy, the original white minerals remain unchanged. Arrays in JavaScript come with helpful methods that allow us to iterate over all the items in the array, map them to new items, and even filter them individually. When you want to carry out the same task for all of the items in the array, the built-in forEach method saves you from having to write a full for loop. For example, if you want to log out all of the prices, we can use products.forEach, and then for each product, use it within a function to log out the product.price. The callbacks for all of these iteration methods also take a second optional argument called index, which is the index of the element that we are currently looking at. So for Apple, it will be 0, and for orange, it will be 1, and so on. And this can actually become really useful if you want to do any sibling analysis beyond the current item. Very similar to the forEach method is the built-in map method, which is inspired by functional programming. Just like forEach, map also gets passed in the individual items and its index, but unlike forEach, the whole map function returns a new array that contains the results from the individual callbacks. So here within the callback for map, we are returning a new object that consists of all of the properties of person along with a new property called full name, which is calculated based on the person first name followed by the person last name. So for each member of people with full name, we will have an object that has a first name, last name, as well as a full name. And of course, you can see the full name being logged to the console. Another iteration method that is built into arrays is filter, which can be used to filter only the items that match a particular criteria. For example, from this numbers array, we can create separate arrays just for the evens and the odds. To create these new arrays, we use the filter method, and within the callback, we only return true if the number is even, or only return true if the number is odd. Now, of course, based on the input array, the only even numbers are 50 and 14, and the only odd numbers are 1773, 19, and 59. It is worth pointing out that in programming lingo, functions that return a boolean based on a passed-in argument are called a predicate. Therefore, the two functions that we are passing to filter are predicates for even and odd numbers. A common task with arrays is to find an item that matches our requirement, and JavaScript provides some neat methods for this purpose. For example, consider an array of people with Percy, Wally, and Harry, and we have the age-old task of finding Wally. Arrays provide a find method that take a predicate, and if this is the item that you are looking for, you simply return true. In our particular case, we want to return true if person.name is equal to Wally, and based on this example, the JavaScript runtime will return the object that contains the name Wally, born 1987. Now, if the item that we are looking for is not found, for example, there is no person with the name Jenny, then the JavaScript runtime will return that value that we've looked at 100 times called undefined. Now, this poses a bit of a problem when the item that we are looking for is in itself undefined. For example, if we try to find undefined within this array, we get back undefined, but we can't be sure if we have actually found it, because if we search for 4 as well as an example, we would still get undefined. And in this particular case, of course, it is because 4 is not found. So there is an alternative method called findIndex, which returns the index of the found item. And there is no ambiguity here, because if the item is not found, it returns -1, and -1 is not a valid array index. Another use case of the findIndex function is when you want to use the returned index to look at some of the item's siblings. For example, here we can see that the item before undefined has the value 3. Sometimes you want to take a smaller subsection like a slice of an array as the new array, and for that we have the built-in slice method. Consider a simple array consisting of animals: ant, bison, camel, duck, elephant, and we want to get everything starting at index 2. We can use animals.slice to get back those items camel, duck, and elephant. We can also pass in a second argument to slice to provide the index from where we want to start excluding. For example, here we want everything starting at index 2 but before the index 4. And if you want to start from the beginning but terminate before a different value, then pass in 0 for the starting index, and of course provide the second argument where you want to terminate. Here we are grabbing only the first two items, ant and bison. As a matter of fact, you can actually call slice without any arguments, simply to create a copy of the array. One thing to note is that the returned array from slice is always a copy and not a reference. As an example, let's take a slice consisting of one element. If you push another element into this sliced array, the original array will remain unmodified. The cat is not a part of the original animals. There are some neat methods built into JavaScript arrays that allow us to deduce some collective facts about all of the members of the array. Consider the array consisting of products, some of which are cheap, for example apple is only 50, and some of them are really expensive, for example saffron is 2000. For our example, the definition of expensive is anything that is greater than 1000, so we have this predicate that determines if a product's price is going to be greater than that value. Arrays have a method called sum, which take a predicate function and determine if some of the items within the array match the predicate. If any of the items return true for the passed in predicate, the sum function resolves to the value true. And it pretty much reads like standard English. For example, here we can say that for the products, if something is expensive, then is some product expensive should be true. Similar to sum, there is another method called every, which basically makes sure that the returned value is going to be true for all of the predicates, and if it is, then every is going to resolve to true, otherwise it is going to resolve to false. You could pretty much read this as standard English as well, thinking that for the products, is everything expensive? In this particular case it isn't, which is why it resolves to false. Now even though we isolated our predicate into its own little function, you don't actually have to do that. You can just pass it inline. For example, is some product cheap? We could just check if any of the products are less than 100, and of course apple is, which is why this will resolve to true. And similarly we can do that with every as well. Is everything less than 100? No, it is not, which is why it resolves to false. One of the most powerful functions built into JavaScript and the bread and butter of functional programming is areReduce. The best way to understand areReduce is with a simple example. So consider this array consisting of 5 numbers 1, 2, 3, 4, 5, and your mission, should you choose to accept it, is to find the sum for all these numbers. Fundamentally, we can do that by starting a sum with a value of 0, then adding 1, then adding 2, and so on. And that is exactly what we can do with the simple invocation of areReduce. It takes two arguments. The first is a reduction function, and the second is an initial value for the accumulator. Like we said, we start with an initial sum of 0, which is the accumulator, and then for each iteration, we get past the accumulator as well as the current item we are looking at, and we simply return the sum of the accumulator combined with the current value. So in the next iteration, we get an updated accumulator value, and the process continues till we run out of items. No surprise, the sum of 1, 2, 3, 4, 5 is 15, which is what we get returned as the final result. Now I want to point out that it is conventional to call the accumulator variable the name of the final value that you are trying to accumulate. For example, here we are trying to accumulate the sum, so that is what we would call that parameter. Now, even though we used a simple number for this particular accumulator, you can actually use any data type that you want. For example, here we have the accumulator as a simple object consisting of two members, even count and odd count, both initialized to 0. Our reduction function in this particular case checks if the current item is even, and if it is, it increments the even count, otherwise it increments the odd count. Since our original array 1, 2, 3, 4, 5 consists of two even numbers 2 and 4 and three odd numbers 1, 3 and 5, that is the answer that we expect, and no surprise, when we log out the final results, that is the answer that we get. Something to be aware of is that certain JavaScript methods are mutating, so in order to use them safely and in a pure functional fashion, you need to create a copy of the array. One example is the built-in reverse method. Consider a simple array consisting of alpha, beta, and gamma, and we can invoke the reverse function to reverse the order. So simple reverse is not going to be gamma, beta, and alpha, but what you might not expect is that the reverse function is mutating, so the original simple array is going to be changed as well. It is not going to contain the same reversed order of items, that is gamma, beta, and alpha. Now the fix is quite simple. We first need to create a copy of the array before we invoke reverse, and we already know how to create a copy by using the spread operator. So we spread the better into a new array before invoking reverse, and now the reversed copy is going to be gamma, beta, and alpha, but the original better array is going to remain unchanged. JavaScript provides a built-in method for sorting arrays, and it does it in nlog time, which is the ideal case for comparison-based sorting. But one thing to be aware of is that if you don't provide this function with a callback, your result might not match what you expected. Consider a simple array consisting of two strings, hello and fam. Now if we sort this, we get back what you would sort of expect, which is fam first because f comes before h. Now let's try the sort example again, but this time with the number array consisting of numbers 1, 3, and 22. Now you would expect the sorted result to be in the same ascending order, that is 1, 3, and then 22, but what we will actually get is 1, 22, and then 3. Now the reason for this is that the default comparer internally to sort uses string Unicode code points. So it works fine if you have strings, they come out in ascending string order, but not good if you have other data types like numbers, because this is essentially the same as sorting the strings 1, 3, and 22, and alphabetically 2 comes before 3, so we get 1, 22, and then 3. Fortunately, the sort method takes a comparer function, so let's try this example again, but this time pass in our own custom comparer, which basically checks the difference between the two values that we are comparing, and if a is going to be bigger than b, then we are going to return a positive number. If they are going to be equal, we are going to return 0, and if b is going to be bigger than a, then we are going to return a negative number. And this returning of negative, 0, and positive values to determine if the first item is smaller, equal, or bigger than the second is how the comparer function works. So now we get the correctly sorted array, which is 1, 3, and 22. Now if you want to sort in descending order instead of the default ascending order, my recommendation is to simply replace the order of the parameters, so put b before a, and this provides a nice visual hint for the next person that you are going in descending order. One common mistake that beginners make when working with JavaScript is unexpectedly using empty arrays that do not actually support the standard array iteration methods. JavaScript provides an array function that is designed to create an array of a particular size. So here we are creating an array consisting of 5 items. However, by default, it creates an array that consists of empty items. So sure, this array does have 5 items, but all of these 5 items are what are called empty slots. These are actually skipped over by array iteration methods. So as an example, forEach will skip over empty slots and we will see no log in this particular case. And similarly, if we try to map these items into another array, like an array of 1 to 5, that will not work either because map will skip over these slots. The solution to this problem is quite easy. We can use that beautiful spread operator to take this empty slotted array and create a completely filled array. Now, of course, those empty slots will be filled by the value which you would expect, which is undefined. But fortunately, now we can use the forEach loop. So we can log out the x values and we will see 5 undefined. And similarly, we can map it into any other thing. For example, we can map it into numbers 1 to 5, and that will work as well. Creating empty arrays by using the array function, passing in a number, and then spreading it into a new array is the standard approach in modern JavaScript. Now, instead of undefined, if you want a filled array, for example, you want an array that consists only of zeros, of course, we can use the map function to map all of these undefineds to the value 0. But JavaScript arrays provide another method called fill, which takes a value and fills up all the empty slots as well. So if you want an array consisting of undefineds, use the spread, and if you want an array consisting of some other value, use the fill. Arrays are JavaScript objects, which means that they follow the same rules of equality. So even if two arrays might be completely equivalent structurally, unless they point to the same reference, they will not be equal. Here we have two arrays and they both consist of the same primitive strings, which is car, TV, and remote. Every time we use the array literal syntax, we are actually creating a new instance of an array. So items A and items B are completely different arrays. And if we try to use strict equality between them, we will get back the result false. Of course, items A is going to be equal to items A and items B is going to be equal to items B. And similarly, if we create a new variable and point it to the same reference that is contained within items A, then items C is also going to be equal to items A. And because items C and items A are pointing to the same array reference, if we push an items into that array using the items C variable and then log out items A, since it's the same array, we can see that camera has been added to that reference. Items B, being a different array, is going to remain unchanged, and this is sort of the reason why items A is not equal to items B. Now, if you do want to compare two arrays as equal based on their values, we can actually create a utility function for that quite easily. It's really up to you to define what you mean by equality. In our particular case, we want to make sure that both the arrays have the same length, and then for every item in array A, the item at that index in array A is strictly equal to the item at that index in array B. So if we go back to that example of two arrays consisting of car, TV, and remote, even though they are not strictly equal as far as JavaScript is concerned, the custom function that we wrote, areArraysEqual, will return true for these two arrays because they have the same length and the primitive items within the arrays can be compared using strict equality. As you hopefully saw, there is a lot of power built into JavaScript arrays. So even though the original goal for JavaScript was not for it to be a data processing language, its combined support for object literals and arrays makes slicing and dicing data quite enjoyable. As always, thank you for joining me, and I will see you in the next one.